Good afternoon. Myself, Leelavati, Assistant Professor, Department of Physics, Congo Arts and Science College. Today we are going to see about dielectric properties. What is a dielectric material? Normally, the dielectric material are closely packed. They are not having any free electrons to share with the other atom. And it is also called as insulators or non-conductors of electricity. But when we place this dielectric material in an electric field, what will happen? The positive charge nucleus and the negative charge electrons get displaced from its position, equilibrium position. Thus, the dipole moment produces, and this process is called the polarization. This dielectric material now get polarized. This dielectric material is used to store the electrical energy. Glass, mica, polymer, plastic, all these come under dielectric category. This dielectric have either permanent dipole moment or induced dipole moment when placed in an electric field. Depend upon the property of dipole moment, the dielectric material may be classified into polar and non-polar molecule. Let us see one by one. First one is polar dielectrics. The polar dielectric possess permanent dipole moment even in the absence of electric field. Permanent dipole moment means the centroids of positive charge nucleus and negative charge electron do not coincide even in the absence of electric field. Hence, it provides permanent dipole moment, but there is a lack of center of symmetry. Center of symmetry means two atoms does not align in the same orientation. Hydrogen chloride, carbon monoxide, all these come under the polar molecules. What happens when the electric field is absent means how these dielectric materials get polarized. The polarization of the molecule depends upon the temperature. What happens when the temperature increases, the vibration of the molecule increases, thus the dipole moment changes. Likewise, this polar molecule get uh, permanent dipole moment. The molecule absorb and emit radiation in the infrared region. One is non-polar molecule. The non-polar molecule does not possess a permanent dipole moment. Then they get polarized only when placed in an electric field. So it is independent of temperature. It does not absorb or emit radiation in the infrared region. The hydrogen, nitrogen, carbon dioxide, CCl4, H2O and O2 are the examples of non-polar molecules. The next one, before entering into the dielectric constant, what is a dipole? Dipole is nothing but the center of positively charged nucleus and negatively charged electron get separated. The distance between these two produces a dipole. What is dipole moment means? It's a product of magnitude of uh, dipole and the distance between the two charges is called the dipole moment. Then next one is dielectric constant. Dielectric constant is nothing but the ratio of permittivity of the medium to the permittivity of the free space. Epsilon r is the dielectric constant and the permittivity of the medium is represented by epsilon and the permittivity of the free space is represented by epsilon naught. Why this dielectric constant is important? Because it is used to measure the characteristics of dielectric material. The dielectric constant has no unit. The material with a higher dielectric constant are easily polarized and have a good electrical insulator. This dielectric constant is how it is related to susceptibility is given by epsilon r is equal to 1 plus psi e. The next one is different types of polarization in dielectrics. What is polarization? On the dielectric material, when placed in an electric field, what will happen means Due to the flow of electric charges, the centroids of positive nucleus and centroid of negative electron no longer coincide. Thus, the dipole is induced. The induced dipole moment by the application of external electric field. This process is called polarization in dielectrics. The strength of the induced dipole moment is proportional to applied field. Mu is directly proportional to E, whereas mu equal to alpha into E, where alpha is called the polarizability constant. Depend upon the microscopic mechanism, polarization mechanism. This polarization in dielectric material can be divided into four types. First one is electronic or atomic polarization, ionic or molecular polarization represented by the letter Pi, and dipole or orientation polarization represented by the letter Po, and space charge or interfacial polarization represented by the letter PS. Let us see one by one. Ionic polarization. Ionic polarization happens at the molecular level. For example, dielectric material in an application of electric field, um, an application of electric field, the cation and anion displacement takes place. For example, ionic solids like ceramics, they are popularly used in capacitors. What happen? Let us see the picture. When there is no electric field, means the positive charge uh, proton and negative electrons are arranged in a random manner, whereas when placed in an electric field, negative charged electrons and positive charge are aligned. Cations and anions get aligned, the displacement takes place, thus induced dipole moment produces, which gives rise to high dielectric constant in ceramics. These ceramics are popularly used as capacitors. This ionic polarization takes place in a this ionic polarization takes place in symmetric molecules. It does not occur in covalent crystals. Covalent crystals, this ionic polarization is independent of temperature because we are applying electric field. The dipole moment produces. Ionic polarization is represented by Pi equal to E square E divided by omega naught square 1 plus m 1 plus capital M plus 1 by small m. Then next one is dipole or oriental polarization. Due to the presence of a polar molecule, the polar molecule have permanent dipole moment when placed in an electric when in absence of electric field. What happens when the electric field is applied to the polar molecule? The alignment of dipole moment get increases. Very high dipole moment is produced. It occurs in very high dipole moment is produced. Such type of polarization takes place in asymmetric molecules. For example, polymer. It is independent of temperature. The oriental polarization is represented by mu square divided by 3 kT. For example, let us see the diagram when in the absence of electric field, the molecules, atoms and molecules are arranged in a random manner. If they are placed these dielectric material in the electric field, um, the alignment get changes. Thus, the dipole alignment get changes. It is called dipole or orientation. Next one is phase charge or interfacial polarization. This type of polarization usually occurs in multi-phased material. For example, polycrystalline material, in which the electric charges are partially migrated on the application of electric field. It's usually found in ferrite, semiconductors, and polycrystalline material. The total polarization is represented by the letter P. It is a sum of electronic polarization PE plus ionic polarization PI and the oriental polarization PO and space charge polarization